Howdy! Hopefully in this video you'll be able to see how we're going to apply some of the things that we learned in our last video in a problem situation. Now in class we're actually going to look at word problems because word problems are just awesome. So we'll be getting to that as well. But for now I just want you to see how all of the things that we've been doing tie in with what I just taught you in the last video. So that's what we're going to do. Let's go ahead and we're going to find the y-intercept, the x-intercepts, the line of symmetry, and the vertex. So let us start off with the y-intercept. So to get the y-intercept, I need to make x equals 0. And so I'm going to go y equals 0 squared minus 4 times 0 minus 5. And you may say, but Mr. Powerwater, it's that minus 5 right there. And you are correct. It is that minus 5. And so the y-intercept is 0, negative 5. So we'll start off by making that y-intercept right there. Now, we now want to find the x-intercepts. And so to find the x-intercepts, I need to make y equal to 0. So if I make y equal to 0, I have 0 equals x squared minus 4x minus 5. Now at this point, the only way that we know how to do this is through the quadratic formula. Are there other ways? Yes, but I'm not going to teach you those till next class. Anyway, we're going to stick with the quadratic formula. Now, of course, if we use our brains, we probably want to use the discriminant first. Use our brains, Mr. Powerwater. Use my brain. Yes, use your brain. So, the discriminant, remember, is b squared minus 4ac. So, a, of course, is 1. B, of course, is negative 4. And c is negative 5. So, 1, negative 4, negative 5. So, we'll go ahead and plug those in. We'll go negative 4 squared minus 4 times a times c. And so I got 4 squared would be 16. And then negative 4 times 1 is negative 4 times negative 5 is 20. And a negative times a negative was positive. So it will be 16 plus 20, which gives me 36. Now, because it is 36 and it's positive, that means I should get 2 x-intercepts. So we're going to go on and do the x equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah, okay, so I sang that wrong, but that's okay. I got the quadratic formula right. So here we go. Now we go ahead and put the numbers in. So x equals negative b plus or minus, and then I've already done the b squared minus 4ac, so I've got that easy part here, 2 times 1. So x equals positive 4 plus or minus 6 over 2. So x equals 4 plus 6, which would be 10 over 2, which would be 5. And x equals 4 minus 6, which would be negative 2 over 2, which is negative 1. So 5, 0, and negative 1, 0. So I'm going to go ahead and put those on. 5, 0, and negative 1, 0. All right, now it now asks me to find the line of symmetry. Now remember, we have 2 ways of getting the line of symmetry. Isn't that exciting? 2 ways. 2. Count them. 1, 2. So the first way is to go to the x-intercepts and find the middle, right? And so I've got an x-intercept of negative 1 and an x-intercept of 5. So I can go 5 plus negative 1 divided by 2, and this will give me the x value of the vertex, which is the line of symmetry. 5 plus negative 1 is 4. 4 over 2 equals 2. So that means the x vertex, or the line of symmetry, is at x equals 2. So that's right here. And go ahead and do this in a different color since I'm switching from intercepts to line of symmetry. That and the fact that, remember, the line of symmetry is not actually part of your graph. It's just kind of a helpful piece of it. Note that it splits it in half. These 2 points are reflected across the other side. Now, I want to make sure that I show you the other way of doing this as well. And so I also taught you that the negative b over 2a will also give us the x value of the vertex. So let's try that. Let's go xv equals negative b over 2a. And so I got negative times negative 4 all over 2 times 1. Negative 4 is 4 over 2, which is, again, of course, 2. So that's our axis of symmetry. Now, I know what you're thinking right now. You're thinking, Mr. Power, why did you do both of those? I like math, but I don't love it that much. Well, okay. So sometimes you'll have the X intercepts, and so you'll be able to use that, which is probably easier. Other times, if it doesn't ask you to find the X intercepts, if you're just looking for the vertex, like if you want the maximum or the minimum or something like that, you don't need to go through the whole process of the quadratic formula in order to get that vertex, because you just do the negative b over 2a, again from standard form. But that will then allow you to get the x value of the vertex very easily. Now, keep in mind that we now have the x value of the vertex, which was 2. We don't have the y value yet. So we do have the y-intercept, we have the x-intercepts, we have the line of symmetry. To get the vertex is a point, and so I'm going to have to take that x value and put it into my equation. And so for the very last step, I'm going to go y equals, and I'm going to replace x with 2. So this will be the y value of the vertex. So I'm going to go 2 squared minus 4 times 2 minus 5. So that is 4 minus 8 minus 5, which is negative 9. So when x was equal to 2, y was negative 9. So 2 comma negative 9. And you'll notice that that is right here on my line, 2, negative 9, which is right there. And it's in conjunction with everything else we've done. Now I'm going to do one more step, because I really like to have 5 points when I'm doing quadratics. And so I'm going to go ahead, and you see this y-intercept right here? It is 2 spaces to the left of the axis of symmetry. If this is really a line of symmetry, then it should reflect on the other side of the line. So since it's 2 spaces to the left, I can also create another point that is 2 spaces to the right. I don't even have to do any work for that one. It's just going to be right there because it's going to reflect. 2 left, 2 right. And so now I can draw my final graph, which looks something like this. There you go. I've used the ideas that we learned in the last problem. We also now have the line of symmetry and the vertex, which we can find easily and quickly from the information that we have without having to use a transformation. All right, there you go.